Continuing on with section 2.1, we're going to look at two special right triangles that everybody should know before this course is over. They're going to be critical in what we do next. So hang in there and keep in touch with these. Our objective is to derive those two triangles, and then you just need to know how to work with them. The first one is the 30, 60, 90. I'm going to take a very standard triangle, an equilateral triangle with all sides equal to 2. We just chose 2 for convenience sake, and all the angles are 60 degrees. I'm going to bisect angle 60 with a perpendicular bisector. What that does is it divides this side down here in half. Those are blah. Sorry, this is not actually behaving like it should. That would divide this side into 1 and this side into 1. That would make this angle 30 and this angle 30. So now I'm going to leap to this one right here where we have that labeled. We have this side is 1. This side would still be 2. We know this new angle, and what we really want to find is x. Well, we have done this all day long. That side squared plus the 1 squared is going to be equal to the hypotenuse squared, which is 4, which means x is just going to be the square root of 3. So right here, square root of 3 is our new x. That leads us to the triangle, the 30, 60, 90, that you want to memorize and work with in finding trig functions of exact values. Again, it can be derived very easily, but if you like to memorize stuff, you will want to remember this. Note a couple of things. The 1 is always across from the 30-degree angle, while the square root of 3 is always across from the 60-degree angle. Of course, the hypotenuse is always the longest side at 2. Remember, with triangles of any sort, the longest side is always across from the bigger angle. So we'll keep that in mind. Now, using this triangle that we need to memorize, we can find the sine of 30 degrees without any trouble. The side opposite 30 is 1, and the hypotenuse is 2. So the sine of 30 degrees is a half. Cosine of 30 degrees, well, the side adjacent to 30 degrees is square root of 3, and the hypotenuse is 2. Tangent of 30 degrees, the side opposite of 30 degrees is 1, and the side adjacent is square root of 3. Oh, that is not behaving. It's not me, I promise. This machine is not behaving. Okay, I would actually rationalize this. This would become the square root of 3 over 3, and you may see this later and need to know how to get back to 30 degrees. We can also tell more than just sine and cosine. We can look at cosecant, secant, cotangent. We can also look at the other angle. We can talk about sine of 60 degrees. Well, opposite of 60 is the square root of 3, and then we have that hypotenuse. Notice our cofunctions, we see them coming out the same as usual, as they should. Cosine of 60 degrees, there it goes acting crazy again, it would be adjacent over hypotenuse, which would just be a half. Oh. And then cotangent of 60 degrees, I apologize for this pen just being all crazy, would be the opposite of 60, which is square root of 3 over 1. And again, I would just reduce that down to plain old square root of 3. Now let's look at the 45, 45, 90. For similar reasons, we chose sides to be 1, just to make life easy, and we use the Pythagorean theorem to find that other side, square root of 2. You can memorize these. We can look at sine of 45 degrees. It is opposite over hypotenuse, which we would then rewrite as square root of 2 over 2. We can look at cosine of 45 degrees, which actually is adjacent over hypotenuse, but turns out to be the same. And we have tangent of 45 degrees, which is opposite over adjacent, and that would just turn out to be plain old 1. I'll go ahead and fix this one too. Rationalized, it would be square root of 2 over 2 without that little funny kicked up mark. Okay. Now, what we really want to do is take some of our knowledge of similar triangles and our newfound right triangles and put it to practice in this triangle below and find these sides that are missing. So let's look at the first triangle. I'm saying this is the first one because this is the one I have a piece of information about. I have the 60, I have the 90, this has to be 30. I also have this side of 7. I can work with this. What I'm going to do is I'm going to draw a similar triangle that I can relate to. I'm drawing it in the same fashion so we can look at it. Sorry about those kick-ups, guys. That's the 30, 60, 90. Across from the 30 is always the 1. The hypotenuse is 2. And then that one is square root of 3. Now notice we've developed two similar triangles. From our last chapter, we learned to compare. Square root of 3 is to 7 as 2 is to a. And so I'm going to cross multiply, and I'm going to get square root of 3a is equal to 14. A, though it is weird, is going to be 14 over the square root of 3. And I would probably, in fact, write that as 14 square root of 3 over 3. Now, just for sake of sanity, because that is awfully weird, I'm going to check this real quick in my textbook to make sure that I have not done anything crazy. So I got 14 square root of 3 over 3 for A, and that is correct. So this is 14 square root of 3 over 3. Now what I want to do is I want to go ahead and find M. So I'm going to draw another similar triangle, the same one. The 30, 60, 90. Again, 1, 2, square root of 3. And I'm going to make those comparisons one more time. I'm going to erase this so we can make those comparisons without too much trouble as we go. Alright, the square root of 3 is to 7 as 1 would be to our m. And m is what we're looking for right now. Cross multiplying, I get square root of 3m is equal to 7. So m is 7 divided by square root of 3, which would be square root of 3 over 3. This would be 7 square root of 3 over 3, and I'm going to check him too, and that's exactly right. Yay, it worked. Okay, so we found A here, and we found M here by setting up two similar triangles with our 30, 60, 90. Now let's take a closer look at that other triangle that's left. We have the 45, 45, 90 here. What I know is typically this side and this side are equivalent. So I know if A is 14 square root of 3 over 3, then N has to be the same thing. I don't have to work for him, although I could. Alright, so I know him because I know A, and they're going to be equal by the 45, 45, 90 setup. Okay? Alright, now I want to find Q. So I'm going to redraw both of these triangles. This is currently what I have, not drawn to scale. Sorry. I'm looking for Q, and I know that this is 14 square root of 3 over 3, and this is 14 square root of 3 over 3. I'm going to draw that triangle that I know something about. This is a regular 45, 45, 90 with sides 1, 1, and square root of 2. So comparing them, Q is to the square root of 2 as 14 square root of 3 over 3 is to 1. Cross multiplying, I have Q is equal to, well, that is going to be 14 square root of 3 over 3 times the square root of 2, which is getting a little crazy, but we're going to make it, which is really Q is 14 square root of 6 over 3. And yay, 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 that's what it's supposed to be. So guys, if you did not learn similar triangles and setting up those ratios, you've got to go pick up that skill. And other than that, you have to memorize your 30, 60, 90 and your 45, 45, 90. And we have our new trig definitions in terms of triangles and sides opposites and adjacents and hypotenuses. And if you can get all that squared away, you'll be doing great.